Yeah, hi. Welcome back. We will finish up the last part of pressure. So, in this case, right, you will see that for atmospheric pressure, right, the gas particles in the air are always widely spread out and always moving in a random and in all directions. So, let's say you have a physical room. Inside the room, there's already air. Air meaning got oxygen, hydrogen, and whatnot, and you have a container of water. So, atmospheric pressure is actually the pressure resulting from the air particles, whereas the pressure in the container, the liquid, is actually the liquid pressure. So these gas particles usually experience the pull of gravity. Therefore, gas particles will also have weight, even though it's negligible. However, these weights of the gas particles exert a pressure called atmospheric pressure on every object on the surface. And this can be usually measured by a barometer. This is an instrument to measure atmospheric pressure like this. One thing to take note is that for one standard atmospheric pressure or 1 PATM is actually 76 cm Hg, okay, or 101.3 kilopascal. So a barometer, what is it actually? It's basically you using like a test tube or what's not, and you fill it with water, with a liquid. So generally, we for this liquid we will use mercury as it is less dense, as it is denser than any other liquid, making it more convenient to be used as a baromic uh, liquid. This liquid is then inverted in the container filled with the same type of the liquid, and the space above the mercury in the column is completely a vacuum. Okay. So these are some parts. How do we get the liquid to go up? Basically, you just use a very simple, maybe a delivery tube, and then you just add in the mercury inside, so as to do it. Next, what will happen then? Remember we talked about height of the liquid to actually be able to calculate pressure. So the mercury column in the tube is supported by the atmospheric pressure because the atmospheric pressure will actually be pushing down against this liquid at the side, resulting in the liquid to actually move upwards. Okay, and the height from here until this area here, this height represents the atmospheric pressure. So the vertical height of the liquid column is directly affected by the magnitude of atmospheric pressure. So having higher atmospheric pressure, this height would actually increase. So the pressure of the vertical height of the mercury increased from 0 in a vacuum to 76 cm at the same level of the mercury outside the column. Okay, and one unique thing is regardless of how you tilt the barometer, right, the height will always remain the same. So the vertical level, the height of 760 mm Hg at sea level, even when the tube is tilted, will always be the same. So in a sense, how do we actually go about calculating? So if you want to search for the pressure in A, B, and C, let's look at A first. So what we can do is, we do note that the atmospheric height is 76. So over here, the highest point is 76 cm. So to find the height of A, the pressure at A will be just 76 minus 58. Okay? Then this will be the pressure at 18. Okay, pressure B will be at 76 cm Hg. Pressure C will be 76 plus 3. I know some of you may be confused as to, shouldn't it be 58? The answer is not. The pressure is exerted by the height of this whole thing. Okay, the pressure of where it is from this point until the point at A. Okay, and vice versa. Okay, why does the liquid at a height of 76 has a height of 76? It is usually supported mainly by the atmospheric pressure at sea level. What will happen to the height of the mercury if region X contains air? So this height will actually be lower than 760 because air will also exert their own pressure. So this one will actually exert a pressure pushing this downwards. Okay. Then of course, draw the height of the mercury when the barometer is tilted. So what you can do is you just draw a horizontal line, and you will see this is where the height is. Q will not have it, will not reach, so you'll be having all the material being filled up. Okay. Then a manometer is different from a barometer. In what sense? You can actually control the source of gas from the other side, as it is filled with a liquid commonly used as mercury or even water, and it's used to measure the pressure exerted from a source, okay, like a gas supply. Works on the same principle that the pressure at any point is the same level of a liquid. Okay, so let's say we want to look at the pressure at A, which is exerted by the gas, and this must be the same as the pressure at B exerted by the atmospheric pressure plus the pressure of the liquid. Okay, so students tend to forget adding this part here. So show that the atmospheric pressure is this, and take the height of the mercury as this and density as this. So basically, you use the formula of pressure equals to H height times rope density times G, which is the gravity. You will get the answer. Okay. The diagram would also show a manometer which is filled with mercury. At one end of the manometer, a gas supply is connected. Take the atmospheric pressure at sea level as this and the density to be this. Calculate the pressure at A, B, C, and D in terms of cm Hg. So what we can look at it is at A, right? At A, the pressure tends to be the same as the atmospheric pressure, because at A here, there is no form of liquid that is actually exerting pressure on it. At B, on the other hand, you would see that there is both the atmospheric pressure plus the pressure of this liquid. Okay. Then at C, okay, over here, you would see that you have both the pressure here, the one in yellow, as well as the atmospheric pressure. That's why I just add it up. And finally at D, D would actually have the same pressure as that of B, because they are of the same level and the same height. What would the pressure at A, B, C, D in terms of Pascal? So Pascal is different SI units as cm Hg. Yeah? So for Pascal, right, what you can do is atmospheric pressure, we do know that is it's just a simple conversion, so that will be quite straightforward. So all this is just playing around with conversion. Okay, and of course, what is the pressure of the gas supply? Gas supply would be the same as just D. Why don't we add the atmospheric pressure for D is because over here is a closed system. So there is no need to consider the addition of the atmospheric pressure. Okay, so we have come to the end of this chapter. Just do a revision and you